Oh, is it recording
Hi.
yet?
Not yet. There it goes.
Yes.
What's up,
Hi.
recap?
Hey, whoop whoop. Miss Marshall here. Miss
Miss
Willis.
Fisher.
Y'all know them.
Willis.
So we are getting ready to do another video together. Whoop whoop. And it is dealing with solving systems with matrices. So let's solve. Gonna go ahead and flip over to my paper so we can solve. All right, here we go. So this is week number 3, and we are setting up systems first. So, to set up a system, you are going to have three things: a coefficient matrix, boop, a variable matrix, boop, and a constant matrix, boop. And it's super simple to set it up. Like, it's real easy. I could have made this like real difficult, but it's not that serious. Let's just make it as simple as possible. So,
Yeah.
literally, right. So literally, this is your matrix type situation. You're just going to separate it into three separate matrices, but it should look essentially the same way as it looks right there. So what do I mean? I mean, we're going to separate the coefficients. So the coefficients from the first row is 1 and 2, and the variable that that's going to go with is going to be your x, and we're going to put -7 there. So it's literally the first row, but we put x instead of y, and we only put x. Our second row, it works essentially the same way. You take your coefficients, 2 and -3, and we're going to put y instead of x, and then this is going to be a 0. The reason why it ends up working like that is because when you multiply like you're supposed to, 1 times x would be 1x, and 2 times y would be plus 2y. And ta-da! This is literally the exact same equation right here. So that's why we put x on top only and y on bottom only, so that it reflects how you're supposed to multiply these back together. All right, so let's get all that off. Boop, 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 boop.
That
And
makes so much sense. Oh,
and that's it. Like, we set the matrix up, and that's totally it. And
we
so,
lost Fisher.
oh no, where did she go?
It's okay. She'll come back.
Okay. So this is A times X equals B. This matrix is serving as our A matrix, the coefficient. This matrix is serving as our X matrix, the variable. And this matrix is serving as our B matrix, the constant. And that is very important to know, because that will help us to solve these matrices after we, continue practicing setting these things up. So, two more to set up, and then we're going to solve them. All right,
Welcome back,
let's set it
Fish.
up. Is Miss Fisher back?
Yeah.
Yeah.
Out.
Yes. So glad you could return. All right. So the next example. All right. Before we start, you must isolate the constants first. Or, in other words, get the variables all together and the non-variable numbers all together. So I
What?
isolate constants first. What does that mean? Let me show you. I always do X, Y, alphabetical order. So I'm going to move this -2x to the left side. And so that means it's going to be positive. Well, on the left side, the thing that has a variable is the y. So plus y equals, and then our poor 4 has to go to the other side. So this 4 right here is the thing that has to move. And so when it moves to the other side, it goes from being a -4 to a +4. And now we have isolated our constant. The constant is by itself. Whoop, whoop.
Would I have
Then
gotten it wrong if I had put Y first, Miss Marshall?
no, you wouldn't have gotten it wrong. However, you had make sure that this one you put y first as well, so that when you set up your matrix, your y variables or values line up and your x values line up. So I just
And
literally, instead of flipping it, keep x
and I would
first,
have to flip
y
my
second.
variable matrix too then if I did it that way, right?
Absolutely. So if you put y first, then y, when you do your variable matrix, would have had to been first, versus when you put x first, you put x like literally first.
Makes
So
sense.
just keep
Thank
that
you.
in mind. Okay. So then we do the same thing for the next matrix. We want to move this one over there and we want to figure out what stays, but 6x is already over there to the left. Since I'm doing x's first, I'm going to keep 6x first. And then now that's plus 3y equals, and then don't forget, there's my constant. It's positive 12. Whoop, whoop. And now we just
Yeah.
have to set up the matrix. Let's set it up. Okay, here are my three matrices. Boom. And now I set them up in the same way that I see it. 2, 1, 2, 1. But don't forget, X goes first, and then 4. And then 6, 3, 6, 3. And don't forget, Y goes next, and 12. And that's your matrix. All right, last one to set up is example number 3. Okay, so let's make sure everything's to the no. We got some variables on opposite sides, so we got to fix that. There are no
Yeah.
constants on those two. So the question is, what is the constant? If there is no constant, the constant is 0.
0.
Whoop, whoop. So
Yes.
let's begin. Oh, let's not start with the matrix. Let's rewrite our equations first. 2L plus 2W plus H equals 72. That one was good to go. All right. I got L's first, so I'm going to keep L first. L, I have W's next. So then minus 3W. And then there is no H at all. There is no H. So plus a 0H. Always put that one so that you know what value to put in the H's spot. That doesn't just stay empty. You got to make sure it's a 3 by 3 with numbers in all of the spots. Equals 0. And then again, L is first, but there is no L. W is next, so minus 2W. H is last, so plus H. And then there's no constant, 0. All right, let's set up our matrix this time. Boom times boom. Okay, make these really huge boxes. All right, doing the same thing. 2, 2, 1, 2, 2, 1. And then in the middle is L72. 1, negative 3, 0. 1, negative 3, 0. And in the middle, this time is W and the 0 on the end. And then 0, negative 2, 1. 0, negative 2, 1. And H is at the bottom, 0. And that is how you successfully set up a matrix system of equations.
So, solving systems with matrices. So, in a matrix equation, like Miss Marshall wrote, she had A times X equals B. So, how do we get X by itself? So, it's just like what we did in last week's notes. X is going to equal A inverse times B. I got a lot of questions that said, I wasn't getting the right answer on that Google form. Guys, order does matter. The inverse is going to go in front of B. The way I think about it, my A is in front of X. So when I set up my inverse, it needs to be in front of the B. Okay, so it stays in front of whatever we're trying to solve when we're multiplying. If we had had it the other way around, then we would do it, but we don't set it up that way. So oh, I think I was supposed to write something there.
Yeah,
Multiply
multiply by the inverse.
the inverse. So I answered both questions. You multiply by the inverse. I should have read the question. My bad. Multiply by the inverse. So to solve a system using matrices, this is the rule.
Woo
X
woo.
equals A inverse times B. All right, so we're going to use the calculator. So I was trying to stay with Miss Marshall, but I failed. So we set it up because these are the same examples. Why am I saying that? Because you guys already set these up. in examples 1, 2, and 3. So when I'm setting up my matrix, I have the coefficient times the variable equals this. And I'm not going to rewrite it with the inverse. So we say A, this is my X, and this is my B. So when we type this in our calculator, so let me get up the calculator. I'm going to go to second matrix. I'm going to go to edit. And this is a 2 by 2 for A. We're putting A in the A spot. And we're going to type in our coefficients. 1, 2, 2, -3. And we're going to do the same thing for B. So we're going to go back to edit, second matrix, edit, B, and I have a 2 by 1 this time.
It's not a
So
1 by 2?
no, Miss Marshall, it is rows by
Oh,
column.
yeah.
So
That's
rows are this way. 2 rows. Good question.
it.
All right. So, and your calculator, so had we put a 1 by 2, it should look like the picture. So they're stacked on top of each other, which is what we want. If we had done it the other way, they would be stacked next to each other. All right. Now that I've typed them both in, I am going to type this into my screen. We want, well, not the x equals part, but we want to type in this green part, A inverse times B. So I'm going to go to my screen and I do second matrix. We want A inverse times matrix B. And we just hit enter. So the top is X. So this matches the variable. So since we have X on top here, so let me, so what is it? -3, 2. So we know, we said, so because this is what we're trying to get X by itself, right? We said X equals here. So when we say X equals, it's XY equals that answer we just got, -3, -2.
Mm-hmm.
So if we were to write this as a system, it would be the point where it crosses is -3, 2. So we don't have to do elimination. We don't have to do substitution. Why did you learn all that? Because it was helpful. All right. So this one right here, I'm just gonna quickly, it's 2, -1, 6, 3. Then we have XY. And then we have equals for 12. Now, Miss Marshall got it all in order for us. So that's why I still have my redid the order. So now we just go straight to our calculator and we type it in. This would be a good time to pause the video, oh, and see if you can do it. Welcome back.
Do we have to write that out every time?
No, ma'am. It's pretty easy. I think because like you can just look at this. It's 2, -1. So I'm going to put a 1 there. And then 6, 3. So really, you don't have to write it out every time. It's helpful, but you don't have to.
But just make sure that you make it so that the variables are all on one side and the constants are on the other. Because other than that, you could mess this thing totally up.
Yes. And the question I asked earlier, like, what if I did put y's? Like, if you're going to put y's first, you have to be careful with your mind, knowing that the y's are on top now when you get your answer. So then we have a 2 by 1, and it's 4, 12. Again, hopefully you did this problem for me. Second quit. I already have A typed there. I'm going to put inverse, second matrix times B.
So I don't have to press the multiply button?
No, you can, but when there's no operation between, it's multiplication.
Oh, okay. Saved me a step.
Yes. So my answer here, and I can't see it anymore, is 2, 0. So again, x equals 2, 0. If we were to graph those, they would cross at 2, 0. That's the solution. All right.
All right.
Let's see. I need to do 2, 2, 1, and then I have 1, -3, 0, and then I have 0, -2, 1. So I'm just going to write that one out, and then we have, so see, sometimes I just do this because that's all I need to be able to see, but you can still write out all your notation. So pause the video and see if you can do this one. We're almost done with the calculator. This time, though, it's not a 2 by 2. What's it going to be, guys?
3 by 3.
Yes, 3 by 3. So I got 2, 2, 1, 1, negative 3, 0, 0. Whoa, whoa, whoa. My calculator did not like me hitting backspace. 0, negative 2, 1. Okay, and then we have to also change matrix B.
3 by 1.
Yes, good job.
Yes.
Speed. 72, 0, 0. And then, guys, we go to the home screen. Now, since we've been doing this, honestly, if I just hit enter, it's going to do the same operation, and then there's my answer. Or I can up. Yeah,
But
right?
that's decimals.
Crackle and pop.
It is decimals, but decimals are okay. Like, they are still numbers. They are terminating decimals, so technically that is exact. Or
Oh,
if
okay.
decimals bother you, you can hit math frac too, friends.
I'm bothered.
So we have those fun right here. Now
Wait, is there a way that we can check this? Like, I don't know. I really don't like decimals or fractions. Can we check it?
Yes, Miss Marshall. What you can do is, so we found what we found. We got this pink right here times this blue letters equals this. So this is L, W, H. So what we can do, we found this guy. So we can do A times my answer. So let's do that. So
And then we should get like 72, 0, and 0.
yes, good question. But remember last class, we couldn't scroll up and do all that stuff. So if you're going to check, you have to do A and then hit second answer. Because we want the previous answer. And we hit enter. Right answer. That's so
That's
nice.
banging. That's
Yes.
banging.
So guys, I'm not going to write this answer down because my calculator goes away. There's the answer for you guys to write in your notes.
Pause the video so you can see the answer because it's going to go away fast.
Yep. All right. Last problem. I'm not going to, let me see. Let me check. Do my variables line up? The answer is yes. So I can go straight into this calculator. I don't have to set it up. I'm going to go to edit. I know it's a 3 by 3 because of this right here. 3 by 3. So back to my calculator. 3 by 3. And I'm going to type in 1 because that's what's in front of x. Negative 2, 1. Then I have negative 4, 1, negative 2. And then I have 2, 2, negative 1. And then I just need the constant matrix 3 by 1. And that was negative 4, 1, 10. Whoa. 0, 10, enter. And then we do second quit. Now that I've done though this, I can't hit enter. I have to get I can scroll up, but I feel like that's doing too much. And then second matrix of B. So it is always A inverse with this because our variable matrix is behind the A. And then there's my answer, 2, 1, 4. So in this problem, you would say, if sometimes they might ask you, what does the Y value equal? Like that could be a question. So I wouldn't write down the whole matrix. If I said, what does the Y value equal? What would my answer be, guys?
1.
1. So if they only ask for 1, you would still do the same work. Y equals 1 and Z equaled, I don't know.
Negative 4.
Negative 4.
Thank you. But they can't always ask you for just 1. Okay? All right. I'm going to switch it over to your friend Fisher.
So we're going to be solving word problems with our fancy new way of solving with our matrices. So you're basically going to be doing the same kind of thing. You are going to first read your word problem, but then we have to set up the equations ourselves, and then we are going to solve using our matrices. So with our first example, it says, suppose you're going on a vacation and leaving your dog in a kennel. Bow Wowery charges $25 a day, which includes a one-time grooming treatment. The Pooch Pad charges $20 a day and a one-time fee of $30 for grooming.
Pooch
So we're
Pad,
going to
I
first
like that
write a
name.
system. They're great names, both of them. So we're representing the cost C for both of these. So we're going to say C equals, if we're staying at the Bow Wowery, we have a charge of $25 a day. So $25 a day. I think that's all we got there.
Mm.
All right. The other one, our cost is going to be $20 a day and the one-time fee of $30. Now, we're supposed to be finding the number of days for which the costs are the same. Now, IRL, I probably would not be solving this with matrices because this is set up really well to solve with substitution.
Or you just
But
set them
since,
equal to each other, right? Couldn't I just do that if I didn't want
Which
to do
is a
matrices?
substitution, right?
yeah, that is substitution. So that's probably what I would do. But since we're working on this method of solving with matrices, I'm going to show you how that would work. So I would bring all the variables to one side. So C minus 25D equals 0, and then C minus 20D equals 30. And so we would put that into our matrices. So you would come over here and do second matrix and edit matrix A into a 2 by 2. And then our matrix would be 1, negative 25, 1, negative 20. And then our second matrix would be matrix B, which would be a 2 by 1. And we'd have 0 and 30.
Mm-hmm.
And then we would quit out of that and then solve by doing A inverse B. And
Oh,
we get 150 and 6. Now the issue here is that you have to make sure you know which number represents which variable. So do either of you, Miss Willis or Miss Marshall, know which one is the 150 and which one is the 6?
I think 150 is the answer because it's the one on top.
and I 150 kind of is more of a cost just because of how
Why?
big it is. Plus, we also have C's in the beginning.
Oh,
Yeah,
so
so
C is first and 150 is first. They go together.
if we'd actually set up our matrix equation, the top would be C and this would be D. So the first number is in fact the cost. This question's asking us for the number of days for which the cost is the same. So the second number is our answer here. So 6 days is our answer.
Makes sense.
And that's more realistic. I mean, if you're putting your dog in a kennel for 150 days, maybe you shouldn't have a dog.
You should probably just load him for
Perhaps
her.
not.
Sell him. Goodbye. Give him to a.
Oh, if your vacation's a week long, which kennel should you choose and why? So if D is 7, which one should you choose? So you want to substitute in 7 and see which one costs less, I'm guessing is what they want you to do. So
Unless you want to spend
let's
some
just
money
check out
and
the
you
cost
bought
here. Yeah, and maybe you have a preference for the one of them over the other. Maybe one has better accommodations in your opinion. I don't know.
Also, for those of you that
So I'm
took
just
the ACT, SAT, this is like, it doesn't specifically say use matrices, but like when it's hard systems of equations, this could save you a lot of time on the ACT, SAT.
Mm.
All right, so if your vacation's a week long, I substituted in the 7 into my handy dandy little calculator. The first one up here, even though it's $25 a day, once you go past 6 days where the costs are the same, the one that's $25 a day that includes the one-time grooming treatment ends up being cheaper in the long run. So you should choose the Bow Wowery.
Roof, roof. Bow wow wow, yippee yo, yippee yay.
Wait, wait, I'm confused. I got
What?
confused. It says that the Bow Wowery costs $175 at 7 days, and that the Pooch Pad only costs $170.
Oh,
Wouldn't I go to the Pooch Pad?
oh,
Oh, I'm not looking right. You're smart.
oh. Okay, not bow wow wow, yippee yo, yippee yay. Pooch pad.
Pooch
Mm,
Pooch
Pad.
pad.
I had a good feeling about Pooch
you
Pad at
are.
the get-go. I'm just saying.
It was cheaper a day. That's what I'm saying too. I agree.
Oh, it's a good thing we're working together.
Amazing.
Pad for the win.
Yes,
Got
ma'am.
it.
Okay, good. All right. Our next question. A cashier has 25 coins consisting of nickels, dimes, and quarters with a value of $4.90. If the number of dimes is one less than twice the number of nickels, how many of each type of coin does she have? All right. There's a lot of information here. One thing you really need to pay attention to is how many unknowns you actually have. Nickels, dimes, quarters. So that's 3 items that you have there. When you have 3 items, that means you're going to have 3 equations. So in terms of matrices, we are going to have a 3 by 3 matrix. So out of this tiny little word problem, we are going to have to come up with 3 equations.
Is it always a square matrix?
So usually one equation. What a great question. It usually is a square matrix, yes. I don't know if it always is. I would say probably 99% of the time it is.
So always.
And I'm only saying that because I'm not 100% sure, but I'm pretty sure it always is. All right, so 25 coins consisting of nickels, dimes, and quarters. So with these problems, you're going to almost always have one equation that is going to talk about the number of items that you have. So that is one of your equations. So this is number of objects. So that's one equation. So we have nickels plus dimes plus quarters is going to equal 25. And then it says with a value of $4.90. So that's a second equation to talk about the value of your coins. So this is a value equation. So the value equation, you then need to set up how much each of these is going to be worth. So if I had, for example, 10 nickels, how much money would I have?
50
Miss
cents.
Willis? 50 cents. So how did you figure that out?
10 times 5, because a nickel is 5 cents.
Okay, so you multiply 10 by 5 cents. Well, right now we don't know how many nickels we have. The number of nickels we have, that's just an unknown right now. That's just n. That's the number of nickels we have. So what we're going to do in this value equation is we're going to say the number of nickels we have times the value of a nickel, which is 5 cents. So we do
Not
that.
0.5.
No, because that would be 50 cents, Miss Willis.
Oh yeah, I forgot the
So
pre-cal.
then we're going to do the same thing for dimes. Each dime has a value of 10 cents. So 10 cents for each dime. And then each quarter is 25 cents. First sentence, we're getting 2 equations out of that. All right, and then the last sentence is going to give us our third equation. If the number of dimes is 1 less than twice the number of nickels, how many of each type of coin does she have? And right now, my two equations that I have are already listed in nice order. I've got N first, then D, then Q. So I'm going to write this equation off to the side. The number of dimes is 1 less than twice the number of nickels. So twice the number of nickels less 1. Okay, so I wrote that off to the side because I want to reorder that so that I have N listed first, then D, then Q, and then my constant off on the other side. So if we reorder that, we're going to have negative 2N.
We can do that? A negative? Like what?
Yeah, because I'm just moving it over to the other side.
Oh, okay.
And then 0Q equals negative 1. Okay.
I think we should type in the calculator now.
Yes. So this is definitely not one that you want to solve by hand because it's gross.
No.
Super gross.
So unlike the pooch pad and bow wowery, I would not choose to solve this with substitution or elimination. You definitely want to go to your calculator. So we're going to matrix, edit. We're going to make matrix A a 3 by 3. And we are going to have our first equation has all ones for coefficients. Then our value equation has 5 cents, 10 cents, and 25 cents. And our last equation is negative 2, 1, and 0. All right, second equation, or sorry, second matrix. Matrix B is a 3 by 1 and has 25, 490, and negative 1. All right. Okay. And so we solve, we get 3, 5, and 17. So again, the order was nickels, dimes, then quarters. So our answer represents nickels,
3 nickels,
dimes,
3 dimes. Oh, 5
and then
dimes.
quarter.
17 quarters.
On quarters.
Yes.
I'm rolling in the dough with the quarters, honey.